So today we're going to talk about the case study. There is a homework that you can practice, but it does not count for a grade. Just the quiz counts for a grade. So case study unit 1. But I'm going to do some of the problems out of the homework. See, I might be able to. Let's do split screen. How about that? Can everybody see that? I think you might like these better than the other questions because there's no definitions to know. You just have to know how to use matrices. So consider an economy with 3 sectors: chemicals and metals, fuels and power, and machinery. And we're going to consider this economy to be closed. So there's only these 3 sectors, and everything's contained. Okay. So chemical sells 30% of its output to fuels and 50% to machinery and retains the rest. Fuel sells 80% of its output to chemicals, 10% to machinery and retains the rest. Machinery sells 30% of its output to chemicals, 30% to fuels and retains the rest. And we're going to fill out this table. The book will make diagrams, and I think the diagrams are good. So we'll say this is chemicals and metals. And we have fuels and power and machinery. So it says that chemical sells 30% of its output to fuels. So we're going to use a 0.3 weight on that line. And we're going to show the direction just to show which way it's going. 50% to machinery and retains the rest. So what would be the rest? What percentage? 20%. So we're just going to have a little arrow that goes into itself. That's 20%. Okay, so that's how you draw the diagram. Fuel sells 80% to chemical. It sells 10% to machinery. And it retains the rest. So what would be the rest? Another 10%, right? And machinery sells 30% to chemicals. 30% to fuels, and would retain the rest. So how much is the rest? 40%? 0.4? So that would be the diagram.
You need a diagram?
You don't have to have a diagram.
It's easier to, like, fill stuff in and
You can fill it in without the diagram. Yeah. I think the diagram's good though, but you'll see more diagrams like this later on, and later on you'll actually call them graphs. There's this whole theory of mathematics called graph theory, and it's about looking at diagrams like this and analyzing them. Okay, so this table that it wants you to make is output from, and this says purchase by, but we'll say input to, right? That's okay. So we have chemicals, fuels, machinery. Let's just call this C so we can use a variable C. Input 2, chemicals, fuels, machinery. So you can go from the diagram or you can go from the text. If we look at the output from chemicals, 30% goes to fuels. So chemical to fuels, 0.3. Chemicals to machinery, 0.5. And then chemicals to itself is what it retains. It retains the rest. So that's going to be the 0.2 that it retains to itself. If you add up the column, it should equal 1 for 100%. Okay? And then fuels, 80% to chemicals, and 10% to machinery, and then it retains the rest, which would be the other 10% that's left over. And then machinery, 30%, 30%, and then it retains the rest. So that's how I'm going to fill out this table. There we go. Thanks. It does matter how you orient this, right? You can't just put don't put these in the rows, because we're going to use these rows to make equations, and it's going to match how we would write a system of equations in a matrix. Now the matrix won't be this table, okay? Don't just take this table and put it in a matrix. We have to do something else first, but let's see if the table's right. That's fantastic. So it says develop a system of equations that leads to prices at which each sector's income matches its expenses. Then write the augmented matrix that can be row reduced to find these prices. So the price for each output, we're going to multiply by each percentage, and it's going to equal the total price input for that sector. So the equations would be uh, 0.2C plus 0.8F plus 0.3M equals C. Just like that. And C is going to be the price. Yes?
That's C and that's C on this side.
They are the same.
Yeah.
Yes. So then second equation, third equation. So we have to do a conversion here because you want all your variables on the left, all your constants on the right. Right? That's how you set up your system. And you want your when you do your matrix, right, you want all your variables in the same order. So we have to move the C, the F, and the M from the right side to the left. Okay. So if I subtract C from both sides, what do you get? You get 0.2C minus C, negative 0.8C, right? And you get a 0 on the right side. There's not a constant here. Same thing with the F. I got to subtract F from both sides. And I get a negative 0.9 F. And the last one, I have to subtract M. So I get negative 0.6 M. So there is my system that's ready to go into the matrix. So really, once you fill out the table, you have the system. You just have to convert it so that all the variables on the left. And it works out that way by how we set it up. Yes?
How did you get the first row?
I subtracted C from both sides. So I have 0.2C minus 1C is negative 0.8C. And I did that for each one. Subtracted F, and then I subtracted M on the third one. So in a matrix form, right, the augmented matrix would be this. So I'm going to put that in, see if we're right. So I got 3 rows and 4 columns, correct? That was well done. So that's really the hard part. The hard part is just setting it up. Once you have a system in a matrix, you can put it in the calculator, row reduce it, and find the solutions. So it says we're going to solve it to find these prices. So P chemicals, P fuels, and P machinery, that's going to be our CF and M. Okay. So let's put this in a calculator. Row reduce. We get this. Do you think this matrix is too hard to row reduce by hand?
I feel like it's gonna get harder.
It's not too bad. You know, you would start out by multiplying every row by 10, right? And then just go from there, and it's, you know, it's going to be long, but it's not any worse than any of the others that you've done, right? So you would just start out by just multiply every row by 10, and then you can start doing other things. Yeah.
Is that, do we have to do that part by hand?
No, you
Okay.
don't. I'm just saying that, you know, I use the calculator, but, you know, and just because there's decimals in it doesn't mean that it's hard necessarily. And just because there's fractions in it doesn't necessarily mean it's hard. Okay, it just depends. Okay, so how many solutions are there? Infinitely many, because I have a free variable. Yeah. I don't know what happened to my matrix. It got wonky there. So the free variable is machinery, right? So I have chemicals equals 17/16 machinery, and fuels equals 11/16 machinery, and machinery is itself. So if I knew the price for machinery, I would know them all, right? I just have to know the price for machinery. So this says, find a set of equilibrium prices when the price for the machinery output is 40 units. $40 units means whatever units your price is, okay? Not just how many things are made. So 40, if we plug in 40 for machinery, then we just calculate the other two based on this solution here that we have. And it says to round to 1 decimal place, the nearest tenth. So 17/16 times 40, 42.5. So that's chemicals. And then 11/16 times 40. 27.5. So I didn't even have to round. That was excellent. So this problem might look bad at the beginning, but it's not really that bad. But you have to set it up correctly. Okay, so you need to think about where everything goes in that table. Okay, and remember you have to subtract that right side, right, from that in those equations. Everybody okay with that? That's just solving a system, setting it up. Okay. All right. So if you've taken chemistry, you know that those crazy chemists will make you balance equations, right? Chemical equations. And they might have made you do them in these really archaic ways, but we're going to show you the nice, quick, easy way. So we get to use matrices. Matrices make everything better, okay? They do. So we're going to write each compound as a vector. And we're going to, in each vector, we're going to put in how many elements, or let's say how many of each element we have in each compound. And we have to use every single element that's listed in the equation. And we're going to, I like to just write out a vector, a generic vector that tells me what those are. So let's just write out our generic vector. I don't even know how many I have here, but 1 is Na. Is that sodium? Yeah. I don't remember my chemistry. It's been a long time. I think 10th grade is the last time I took chemistry. So Na, H for hydrogen, carbon, oxygen. Are there any others? In the whole thing, all the way over. Is there anything other than those 4?
There shouldn't be.
That's it, right? So this is going to be my generic vector. So I know now that my vectors are going to have 4 inputs, have 4 entries. So they're going to be R4 vectors. So the basis of this process is that we have this conservation of matter, right? Matter is not created or destroyed in this chemical process. So however many of these things there are on the left have to equal all of these things on the right. Okay? So I'm going to list out those in my vectors and set up an equation. So let's say the first compound has 1 Na, it has 1 hydrogen, it has 1 carbon, and it has 3 oxygen. Does everybody agree? We'll call this C1. Compound 1, okay? And it's a vector. Vector C1. Plus the second compound. I have how many hydrogen? I have 8. So I'm going to put an 8 there. I have 0 Na, so let's do that. 6 carbon and 7 oxygen. And I'm going to write equals. C3. So 3 Na, 6 carbon, 5 hydrogen, 7 oxygen. I'll run out of room. C4. H2O, water. So 0, 2, 0, 1. The last one, CO2, carbon dioxide. So 0, 0, 1, 2, like that. Sorry if you can't see that. I squeezed that in there. Yes?
Are we not going to multiply that by 3?
We will. That's next.
So this is all from the original.
Yes. Yeah. So we want to know how much of each compound is going on in order for these to equal out. Okay. And I'm given that this guy's 3. There's 3 of these carbon dioxide compounds. So all these others are multiplied by how many of them there are, right? And we're going to write that as a one vector, we'll call it x. So we'll say x1, x2, x3, x4. Let's go ahead and throw an x5 in there. Even though we know it's 3, let's just see what happens. So like the previous problem, we want everything on the left side. Okay? So I'm going to rewrite this. X1 plus X2. Try to write smaller this time. Plus X3. And because I moved this to the left side, I have to multiply it by -1. Right? So I'm just going to do it inside the vector. I didn't give myself a lot of room. And then that has to equal 0. So I just took those vectors on the right side and moved them to the left, and I multiplied them by -1. Right? And I decided to do it inside the vectors. So we're going to set up a matrix for this, right? This is a matrix equation. Well, the way it's written, it's called a vector equation, right? But we could turn that into a matrix equation. So we know there's 0 on the right, so I'm just going to erase that so I have room. So here's my matrix. And it's augmented with zeros, the 0 vector. That's how much of the first one, how much of the second one, how much of the third one, how much of the fourth one, how much of the fifth one. And I'm just going to put this in my calculator. We'll call it B this time. So B is 4 by 6. That one's not right. Yeah, I didn't do something right. There we go. That looks right. Okay. Row reduce. Let me get this. So, do I have a free variable? Which one is it? X5. And it told us what X5 was, right? X5 is how many of the last compound, right? So that's 3. So it gave us 3. Why did it pick 3? It was convenient, right? So we'll say X1 is X5, right? X2 is 1/3 X5. X3 is 1/3 X5. X4 is X5, and so is X5. And if we let X5 be 3, it means X4 is 3, X3 is 1, X2 is 1, and X1 is 3. So that's how many of each compound is present in this chemical reaction. Yes.
So you could balance any chemical equation like that?
Yeah.
Oh, nice.
Yes.
What if there was 3 on the left and 3 on the right? Wouldn't that be 6, but only 4? And since there'll be 2 free variables.
Say it again.
So like we're adding, there were 3 items on the left of the equation and 3 on the right. Like right now there's only 2 reactants and 3 products, right? So if there was 3 on both sides, that'd be 6 columns and only still 4 variables. Wouldn't that give us 2 free variables?
You could get multiple free variables, yes.
And then how would you do that if you only need 1 value?
You would need to know how many of that other, you'd need to know 2 of them instead of just 1. You'd have to have some kind of given information.
So even if it was just 1,
Usually you know,
same value for the other one, right?
usually you know what's going in, right?
Yeah.
It's what you don't know what's coming out. That's what you're trying to figure out. Now we happen to know what came out. Maybe we do know that, but I mean, you would need to know if you had 2 free variables. You need to know two of the compounds to figure it out. Anybody else? Questions? All right, this might be my favorite. This is definitely what we'd call a graph. Okay. I don't know if I can make that bigger. Let me see. I don't think that did anything. Can you see that graph? All right, let me just draw it bigger. How about that? So we got these 5 points. A, C, E, that's fine, D, and we got B in the middle. And it's called a network. It could be like traffic flow or water irrigation, or it could be computer network, information flow. It could be electrical network. So we know 30 coming in, 20 coming out, 80. That looks right. Let's say that this is traffic. That's just for an example. So that 30 at the top going into A, that means 30 cars are going into A and 80 cars are coming out that way. And then we have two other things that are unknown. How many cars are coming from B and how many cars are going out to E. Okay. But we know how many are going in to A from, say, the north and how many are coming out west, okay, at a given time, okay, etc., right, the rest of the graph. And we don't know what's going on in the middle. We don't know what's going on in between. We just know the input and outputs outside of this. So for the same reason in the last problem, there was no matter that got created or destroyed in that chemical reaction, right? There are no cars that get created or destroyed when they go into these intersections, right? So whatever, yeah, well, I mean, if they get hit, they're still there, right? They can be totaled and wrecked, but they're still there. So whatever goes into A has to equal whatever comes out. So for every point, you can write an equation, right? Whatever goes in total has to be whatever comes out in total. So for, let's just say, just for intersection A, right? Going in is x2 and 30, and coming out is x1 and 80. Does everybody see that? So that means x2 plus 30 has to equal x1 plus 80. So that's our equation. x2 plus 30 has to equal what's the other one? x1 plus 80. It doesn't matter what side you put those on. Okay. Now, for our purposes, we want to put these in a matrix, right? We want the variables in order on the left side, and we want the constants on the right side. So let's go ahead and change this the way we want it in our matrix. So I'm just going to move the x1 to the left. I'm going to move the 30 to the right. Right, subtract it. So that's an equivalent equation for that intersection A. Let's just do this, and then we'll go back to the question. All right, let's look at B. What's going into B? X3 and X5. And coming out is X2 and X4. So X3 plus X5 has to equal X2 plus X4. So X3 plus X5, I feel like I got it right big now, equals X1 plus X4. Is that X1? I think it's X2, right? Let's make sure. X2, yeah. All right, so now we want to rewrite it so it'll go into the matrix. So X2 first, X3, then the X4, got to bring it over, X5, and that's got to equal 0. Right? There's no constant in that one. C. So x6 is going in and 80 is going in, and coming out is 20 and x5. So we can say x5 plus 20 equals x6 plus 80. Doesn't really, again, it doesn't matter what order those are in. x5 plus 20 equals x6 plus 80. And again, we want to write it so that it'll go into the matrix. We want all the variables on the left. We want them in order. All the constants to the right. Let's do D and E right here. So D, bottom right. So x6 is coming out, and 80 is coming out. x4 is going in, and 40 is going in. So x4 plus 40 equals x6 plus 80. We want to rewrite this with the variables on the left in order and the constants on the right. Last one, E. So we have x1 going in and 60 going in, x3 is coming out, and 30 is coming out. So we'll say x1 plus 60 equals x3 plus 30. x1 plus 60 equals x3 plus 30. Rewrite it. So we have an equation for each intersection. We're going to write those out. So this one's negative x1 plus x2 equals 50. That's A. B. C. D. And E. And you'll just put this in a matrix. An augmented matrix, right? Augmented matrix. And it's, good to know how many columns you're going to have to start with, right? So, on a problem like this, I would just go ahead and kind of lay out your matrix so you make sure you don't mess up. It doesn't mean you're not going to mess up, but Now this is a 5 by 7 matrix, but it's actually not hard to row reduce because it's just full of ones and zeros and negative ones. This thing would be a breeze to row reduce. It's not difficult. I said it was a breeze. I guess I'll have to do it. All right, so let's multiply the first row by -1. Let's add the previous version to this last row. I'll leave the others alone. Let's add row 2 and row 4. Yeah, I want to do row 1 too, so. So I'm just going to take this 1 and use it to make these 0. See that? All right, so it's going to add. Add here. Let's switch these 2 rows. So I got this pivot and this pivot. I need So I need this 1 here. So I need to swap those two. So I got pivot, pivot, pivot. I need to make that -1 a 0. If I've messed up already, you need to tell me. I mean, we'll check it. All right, so going to add those two. So 0, 0, 0, 0, 1, -1, 60. Pivot, pivot, pivot. That's a pivot. I need to make that one 0 below it. And then I'll be done. Maybe. Might be done. Oh yeah. Well, they're just the same, right? So let's get zeros on the bottom. 6. So that was a breeze, right? Let's check it in the calculator. Call it C, 5 by 7. Yay, I did it. Okay. So this thing has free variables. Which ones are free? So here are the pivots. X3 and X6. Right. Those are free, so we have two free variables. We're going to write the solution in terms of those free variables. So X1 is X3 minus 30. X2 is X3 plus 20. X3 is X6 plus 40. I'll skip that one. X3 is free. X4 is X6 plus 40. X5 X5 is X6 plus 60. So your first thing is you have to pick the right format, right? So which one is the right one? C, right? C's got the right free variables. So pick C. X1 is, so X subscript 3 minus 30. X subscript 3 plus 20.
Oh, never mind. I was thinking you put the subscript 20 with 3.
Oh, did I? Yeah, you're right. Thanks. So it wants to know the minimum flow. So X6 can be 0. X6 can be 0, and that would mean the minimum flow for X4 and X5 are 40 and 60. Do we see that? So that one's easy. So X6 could be 0, so 4 and 5 could be 40 and 60. That would be their minimums.
And X3 would have to be 30 because I got the negatives.
So the smallest that X1 can be is 0. So that means the smallest X3 can be is 30.
Does it say anything about it can't go into negatives?
I don't know if it says that, but we're going to assume that. Like if it's cars, you have a negative number of cars. Okay, this is actual flow of something going through, so we're not going to say negative. You know, sometimes you use negative for direction, but we're using those arrows for our directions. So, you know, we didn't call this up 40 and this down negative 30. You know, we just used 30 and 40. Okay, so that means if the minimum for X3 is 30, then the minimum for X2 is 50, right? So 50 and 30. Yep. So the minimum for x3 is 30 because if x1 can't be negative. So if x3 was 30, then x1 would be exactly 0. So that means the minimum for x2 would be 30 plus 20. That'd give us 50.
That was a doozy.
It's fun though.
Lots of calculations.
A lot of calculations, yeah. Well, you know, you could have done that in the calculator. The part that's hard is setting it up. You got to set it up correctly, get it in the matrix correctly.
At least this isn't on our test.
No.